Alrighty, we spent the other day kind of exploring. You were cutting out squares with on graph paper, and I was making you glue them together and trying to notice what was going on with the triangle that was formed in the middle. So actually, let me just make this look a little better. So you have these three squares of varying sizes, and I said, get those three corners matching up, and then tell me what you see about the triangle. Specifically, tell me what you can about classifying it by its sides, which means it was either scalene, all three different, isosceles, two of the three are the same, or equilateral. And what you should have noticed then is that each one of these is different. They're scalene. Then I said, take a look at the angles. And even though we don't have a protractor, look at it and see if you can make a pretty good guess as to whether you think by the angles, are all three of the angles acute? Is one of the angles a right angle, which would make it a right triangle? And or is one of the angles obtuse, which would make it an obtuse triangle? So as you looked at that, then if you were really, really accurate when you cut out your squares and got the corners just so, it really does look like all of these are right triangles. And in fact, they are. Now, there was something else very interesting that occurred with the sizes of the squares that I told you to put together. In one of the groups, I think in the first group, you had three squares that looked like this, which meant this side was 3, this side was 4, this side was 5. And I said, do you notice anything math-wise, specifically about the areas? And hopefully what you began to notice is that 9, the smallest one, plus 16, the middle-sized one, add up to equal, oh my gosh, that third side. Did you even notice that? Cool. In the second group, the sizes that we had on those three were, let's see, I think we had a 25, and then this one was really big, so these squares aren't to scale, 144, and 169, where this side was 13, this side was 12, this side was 5, and oh my goodness, do you notice this? 25, 144, 169. Jinkies, Fred. That's amazing. And the last one I had you do, that one happened to be 36 for the smallest one. The next biggest one was 64, so that was a side 6. This was a side that was 8. And then the big square, the biggest one in this grouping was 100 squares, so that was a 10 by 10. And if you look at these, 36, 64. Oh, it equals 100. Holy cow. Well, the reason we had you do that is because I want to lead you directly into something called the Pythagorean Theorem. So, the Pythagorean Theorem, a theorem is like a mathematical principle, a kind of a law, so to speak. It's what happens. And someone went along the way and proved it so that we can take it pretty much as, yep, this is true. I want you to draw a right triangle up here. We know it's a right triangle because we just said it was with that mark. All right. The Pythagorean Theorem. Now, Pythagorean, where this comes from, is the ancient mathematician Pythagoras. Great name, huh? What do you suppose his nickname was? Pithy? Faggy? Gore? I don't know. Gus. Maybe that was it. All right. Anyway, here's what was discovered and then kind of attributed to him is that before they had computers, calculators, levels, all these fancy tools, he said, you know what? If you have a right triangle like this, that these two sides, which we are going to call the legs, and the reason we call them legs is because, hold up this. Remember when your parents taught you how to figure out your left foot from your right foot and they said, hey, hold up your hand and let's figure out which one makes the L. All right. If you do that, do you see how there's a 90-degree? I'll do it this way so you can see. There's a 90-degree angle here. L for legs. These are what we call the legs. They're the two sides. So this is only works for a right triangle. And these happen to be the two sides that form the right angle. Two sides that form the right angle. Okay, let's see. Then we have this other side, okay? This is the one that's across from the 90-degree angle. And this has a delightful name. I can't spell. Hypotenuse, hypotenuse. That's called the hypotenuse. It's the special side of a right triangle because this is the one that's across from the 90. So again, I'm going to say we need to be in a right triangle. This is the only time it works. Okay? It is the side across from or opposite, I'll just say across from the right angle. So it's kind of like the third side. Also, something that you're going to discover as you keep working with more and more of these right triangles is this also will be the longest side. Okay? Now that we have these parts, there is this special relationship that we just talked about here. If I take the side lengths of each of these and square them, it turns out that these two, which is the squared version of each of those numbers, add up to be that one. So how on earth are we going to write this in words? Well, here's what we're going to say. This only works in right triangles. So we're really narrowing our focus in this particular situation of geometry, okay? One of the legs, I'm going to call this leg A. Okay, so I'm going to write it here. I'm going to say leg A, whatever that length is, okay, take that number and square it. Then let's grab the other leg. Let's call that leg B. I'm going to call this leg B. Figure out what that length is and square that. When you add these two together, you get this third side, the hypotenuse, which I'm going to call C right now, side C. You get that number, that length squared. Now that seems like an awfully nasty, wordy thing to remember. So almost every math book is going to say this. Understanding that A and B are always going to be the legs. And it doesn't really matter which one you call A and which one you call B, because you're going to square both those numbers, add them together to get the total. Those two will always equal whatever the length of that hypotenuse side is, which we're going to call C, squared. So let's take a look at a few examples so you can see what I'm talking about. And frankly, I am going to make sure that I get, let me get a new one up here. I'm going to get the calculator up so that we can kind of do this together. Okie dokie. You have your packet and you have your calculator ready. Vroom, vroom, vroom. Well, I jump through my hoops to get this guy up and loaded. All right, here we go. So this first picture right here on example 1 says, hey, here's a triangle. It's a right triangle. This side is 4 and this side is 5. I can find that hypotenuse because I can use the Pythagorean theorem. So that's what they want you to put in this box. Pythagorean Theorem. Okay, one of my legs I'm going to call A. So let's just pick 4. I have to square 4. The other leg, I'll call that B. That's 5. I'm going to let that one go there. And we don't know what C is, but my formula says this leg squared plus this leg squared equals the hypotenuse squared. 4 squared is 16. 5 squared is 25. Add those together and I get 41. Hold your horses. Okay? C squared is 41. So that means if I want to find out what C is, I have to take and undo the squaring by taking the square root. So C squared is 41. That means C is the square root of 41. Cool beans. Here we go. Square root of 41 equals. Oh yeah, this calculator loves to leave it in exact radical form. Oh, now remember, you have to be smarter than your calculator. This number keeps going. It's irrational. It doesn't repeat. It doesn't end. It behaves in this very unpredictable way, which is why we call it irrational. So we're going to round this off to be about 6.4. Okay, about 6.4. That is what C equals, approximately 6.4. Cool. Let's try another one. Turn the page. I don't really like that graph. So let's come down to this guy. Oh, not this one. Pew. Not that one. This one. Oh, I don't have a picture yet. 2 airplanes leave the same airport at the same time. Cool. The first plane flies to a landing strip 350 miles south. Stop right there. Come over here and put a dot right here. This is our airport. Airport. It's my sad excuse for an abbreviation. We're going to fly straight south. Meow. Right there. 350 miles. Let's label it. All right, so that's plane number 1. Zoom. The other plane flies to an airport 725 miles west. West is this way. That's 725. Yeah, I know my picture isn't to scale. Never said I was good at that. How far apart are the 2 planes after they land? So in other words, I want you to find this distance. Ta-da! This is a right angle. That makes this a right triangle. That makes this the hypotenuse. This is C. Ta-da! Here we go. Oh my stars. This is gonna be big. Oh, I guess I started with 725 there. Guess what? It doesn't matter. You just have the 2 numbers, and because we're just adding them together, it doesn't matter what the order is. Let's go. So 750 squared. Holy cow, that's over 500,000. 562,500. Write that down. The other one was, oh wait, is that right? 750? Was it that and 325? Good grief, I'm losing my mind. No, that's wrong. 725 and 350. Guess who hasn't had enough coffee? Forget that number. 725 squared. Here we go. That looks better. 525,625. 525,625. Jinkies. All right. 350 squared. 122,500. Add those 2 together. Simplify by adding. I don't know what they want here. In fact, that's okay. Add these 2 together. All right. When I go back over to my friendly calculator and I add 525,625 equals, we get that. Hey, do you know if you don't have to get each one individually, you could build this as one big thing. 725 squared, that's one leg. 350 squared, that's the other leg. And boom, there you get your answer. So let's get our total written in there. Now, here's what's going to happen with 648,125. That is what C times C is. Okay, C squared means C times C. So to figure out what just C is, the length of this distance, you have to take the square root of 648,125. Holy cow, thank you, person that invented the calculator, because I would not want to try and guess and check this one. Here we go. Just a little bit over 805 miles. Cool. Oops, 805 miles. Good Lord. Here we go. We get a decimal, I think it rounded to be about 0.1, but they say, there you go. All right. Now, there's a second packet, and it's going to be all about Pythagorean Theorem. So, here's what I want you to do. Take that one out. It looks like this. And you're going to do this first page, which is this puzzle, and the second page, which is this puzzle. All right, let me get you started on this first one just so you can see what exactly they're asking you to do. It says determine whether or not the given numbers are possible measures for the sides of a right triangle. So we're going to square each of these, and then we're going to test it and see if it works. Let's do the first one. If A is 6, 6 squared would be 36. If B is 8, B squared, 64. If C is 10, 10 squared is 100. Now, here's what you've got to say. Is 36 plus 64, what does that equal? Does that equal 100? Yes, it does. If you get yes, this says where you see, so it says circle the letters next to the correct answer, find the lowercase letter in a box at the bottom of the page, and write the uppercase letter below it. So we got to find lowercase I, little I, down here, and put capital O. Go back up to the top. Let's do the next one. A is 10. B is 12. 12 squared. It's my favorite number. C is 14. C squared is 196. You got to check. 100 plus 144. When I add those together, I get 244. Is this a right triangle? No. That doesn't match. So this time you'd circle no. Find lowercase t down below in the box. And this is in the way here for a second. Put capital S. I want you to jump and look at number 6. This guy. Because this looks a little weird. 4 squared is 16. 9 squared is 81. What on earth is the square root of 97 squared? I'm going to show you. Get your calculator. The square root of 97. Oh yeah, left it in radical form. Even if you turned it into a decimal, irrational. It keeps going past that last digit of 2. But now I'm supposed to square it because this is what C is. So if you hit the squared button and hit enter, shazam! Look at that. What? The square root of 97 squared is 97? Uh-huh. Because taking a square root and squaring something is like doing something and then undoing it right away. Okay? If I said, hey, take the number 25, no, let's do something like 20. Take the square root of 20. You get a value, turn it into a decimal. If I said square it, guess what you're going to get? 20. You're going to get right back where you started. Okay? So On this worksheet where you see this, not this one, we're back on here. On this one where it said the square root of 97, when you square it, it ends up being just 97. Test this. 16 plus 81. What do you get? I get 97. That's a yes. Okay, come on down. Lowercase a becomes capital H. As you work your way through the rest of these, then check all of these, follow the directions, and see if you can figure out the pun. On the next page here, it says, what comes from space and leads a parade? On this one, you are basically finding the hypotenuse each time. So here, this is your L, these are your legs. You need to take 7 squared plus 12 squared. Well, let's see, 7 squared is 49. 12 squared is 144. When you add those two together, you get 193. C squared is 193, which means C is the square root of 193. Do that on your calculator. The square root of 193 13 point, let's round to the tenths, 13.9. Okay, here we go. 13.9 approximately. We had to round that. This is centimeters. The directions say cross out the letters above each correct answer. So I'm looking down here for 13.9 centimeters. Oh, there it is. We're crossing that out. When you get done with all of these questions, what's left, put in the boxes to answer this riddle. Have some fun, get your calculator, and as always, may the force be with you.